So what we've been doing is been focusing in on the Pythagorean theorem. And we've been discovering that with the right triangle, we have a squared plus b squared equaling c squared, where we can find the leg or solve for the hypotenuse depending on what is given. Well, in 8th grade, we also need to focus in on using the Pythagorean theorem to find the distance. So a lot of times what they're going to do is they're going to give us a story on grid paper or just 2 dots. And our job is going to be able to figure out that distance once given that information. So in these notes, we're going to be taking a look at 2 specific strategies. One when we're given a graph, and the other when we're only given the points. All right, so let's take a look at what this means. All right, so I have an example here of given a graph. All right, and so I have a graph. All right, I have points A and points B, and I want to know the distance between these 2 points. Now, a lot of times what we do is we try to count, and we're like, okay, well, if I draw a line connecting these, and I can be like, okay, well, that's kind of like 1 square, 2 squares, 3 squares, 4 squares, so maybe 5.5. All right, but what we're going to try to do is we're going to try to eliminate the guessing game. Okay, so what we're going to do is we're going to write our steps to solve, and then we're going to actually do them. So I'm going to use different colors. If you have different color pencils, feel free to use so that what we do matches the steps of the colors. All right, so the first thing that we are going to do is we are going to draw a right triangle by connecting the points. Now that is like, wait, what? Okay, and honestly for me, it's like, how do I write that step? So let's explain what this means. All right, so this means I want to draw a right triangle with these 2 dots involved. Now the beauty of a grid is that everything is squares. So I know that I can either have a stop sign right here, or I can have a stop sign in this upper corner, and that is determined by where we would change directions to connect the dots. So following my grid lines, I traveled down, stopped at my stop sign, and then I traveled right. So I'm trying to create this anchor so that these 2 points come together at a right triangle. All right. So next thing I'm going to do is I'm going to go ahead and I'm going to count the squares. So I have 2 squares here, and I have 1, 2, 3, 4, 5, 6 squares as this other piece. Now notice I counted the squares, not the lines. So I have 6 squares that make that line segment. Okay. My next step then is going to be to use the values created. So we just created 2 values, 2 and 6, as the legs. So those 2 pieces are part of my right triangle. And those are the legs of the triangle. I have 2 units and I have 6 units. So that represents my A and my B. So I'm going to write 2 squared plus 6 squared equals C squared. So this distance between A and B is across from the 90-degree angle. So that part has to be C. So then my last step, just like anything else, is going to be to solve. All right, so we would find that 2 squared is 4, 6 squared is 36, which means we have 40 equaling C squared, which means we take the square root of both sides. So this distance between A and B would be the square root of 40. So C equals the square root of 40, which means C is approximately, and if I had my handy dandy calculator, which apparently I didn't prep well enough over here. All right, so when I have the square root of 40, I have approximately the distance of 6.34 or 3.2. Okay. So let's walk through the steps again. We draw ourselves a right triangle on our image, and we count the squares. We use the values of those squares as our legs. We plug that into our Pythagorean theorem, and we solve. All right, so I have a you do for you to try. I want to know what is the distance from point C to point D. All right, so I want to know what is the distance from point C to point D. Now, if you're listening to this video with volume, when you record your answer, can you please write the word, let's write the word cat. So can you write the word cat and then your answer so you can get a bonus point for listening while doing this video? All right, so let's take a look at our answer. So first step was that we needed to create the legs by drawing a right triangle. So personally, I'm going to draw down and that angle here, left or right, however you want to see it. Now you could have done across and down if you chose to, and I'm going to complete this triangle just because it makes my happy face there. All right, so this is 1, 2, 3, 4, 5 squares down, 1, 2, 3 squares across. So that means my legs have to be 3 squared plus 5 squared equals c squared. Well, 3 squared, if I do this in my calculator, 3 squared plus 5 squared, that makes 34. So that means c has to equal the square root of 34. All right, and then when I do the square root of 34, I get that c is approximately 5.83 squares. So remember, when we're solving, we take the square root of both sides. That's what I did to get to that final answer. Okay. So it's great when we have a graph, right? We can count the squares, we can see what's going on. However, that's not always the case with what the information is that they give me. Right? So in this next part, let's take a look when they give me the points. Right? So given the points, now I have this written here and it's like, ooh, that's gross. But I want to explain what it is that we actually wrote. Okay? To find the distance of things that move, we subtract our x values and then we square it. So that is one of our legs. Now, if I look at my graph that I did, notice I am subtracting my x's to find out that total distance. So instead of counting the squares, we're just using subtraction. So we subtract our x's to get leg A. We then subtract our y's to get leg B, and then we plug those values into the Pythagorean theorem. So nothing has changed about what we did, just instead of counting squares, we're using subtraction. Now the question comes up, does it matter the order that I subtract? No, as long as you keep it consistent. So let's take a look at this first example to see what I mean by this. All right, so I have 1, 3, and I have 5, 7, and the question is, what's the distance between these 2 points? Now, I could take out graph paper and I could use our first strategy, but I don't carry graph paper around with me. There's no app on my phone that goes, oh, graph these points. All right, I need to be able to understand the concept behind this. All right, so here's our steps again. Step 1, we need to subtract our x's and subtract our y's. All right, so when we do this, I could do 1 minus 5 and 3 minus 7, reminding myself that my coordinates are always written x, y. However, I like to subtract bigger minus smaller. So maybe I want to do 5 minus 1, and if I choose 5 minus 1, I have to do 7 minus 3. I can't mix and match. All right, so let's do this. All right, so I'm going to subtract my x's, and that is going to become 5 minus 1, which we get 4. I'm going to subtract my y's, which is 7 minus 3, which also gets me 4. So again, 5 minus 1 is 4. 7 minus 3 is also 4. All right. My next step then is going to be to plug my answers in as leg A and leg B. So what we did is we found the change that occurred. To get from one point to the next, how much x's changed, how much y's changed. So there was a 4 and a 4 change. So we're going to plug these into the Pythagorean theorem, which means I'm going to square my x's. I'm going to add my plus sign. I'm going to square my y's, and I'm going to add c squared into the story. And then, last step as always, we are going to solve the Pythagorean theorem. All right, so we get 4 squared plus 4 squared. So 4 squared plus 4 squared. All right, and that gets us 32. Ooh, big 2 equals c squared. And just like with anything else, I need to then take the square root of those answers. So c equals the square root of 32. Or I can do square root of 32. So c, I ran out of room, is approximately 5.66 squares. So let's walk through the steps again. Subtract the x's, subtract the y's, plug those in as your legs, and solve. Subtract the x's, subtract the y's, plug those in as your legs, and solve. So let's do one more together, doing those steps, and then I have a you do for you to try. Okay, so remember our first step, subtract the x's, subtract the y's. So we're going to subtract our x's, and I'm going to go left to right on this one. If you need to write your x's and your y's above so you remember which is which, feel free. So my x's is 10 minus 1, which gets me 9. My y's are 6 minus negative 4. Okay, so remember when we're doing this, minus a negative really means plus. So 6 plus 4 is 10. Subtract my x's, subtract my y's. Now those become my legs. A squared plus b squared equals c squared. And now I'm going to solve. 9 squared plus 10 squared makes 181. I take the square root of both sides, getting me, so take the square root of both sides. So c equals the square root of 181. 181 is not perfect, so I'm going to leave them in the square root symbol. And then I'm going to do my answer, and he is approximately 13.45 squares long. Subtract the x's, subtract the y's, plug it into the Pythagorean theorem. All right, so let's have a you try one. All right, so here's our you do. All right, we have 1, 1, and then we have 6, 13. Subtract the x's, subtract the y's, plug that into the Pythagorean theorem, and solve. All right, so let's check it out. 6 minus 1 will get me 5. 13 minus 1 will get me 12. Plug those into the Pythagorean theorem, so I'm going to square both of them, and that equals c squared. 5 squared plus 12 squared, well, that gets me 769. Oop, I'd have a squared. That didn't look right. 5 squared plus 12 squared, there we go. So that equals 169 equals c squared. I take the square root of both of those. So c equals 13. Boom. Okay. So this content isn't meant to be difficult. We just need to understand that Pythagorean theorem can be used as long as we hit that stop sign, change directions, and have our leg length.